Okay, so a radical expression is an expression with the radical in it or with the square root symbol. This would be an example of radical expression, or maybe square root of 3 over 2, or maybe 5 square root of 3 over 2. These are all radical expressions. It's an expression with a radical in it. And then perfect square numbers, we're going to be looking for these today. They're numbers that have a whole number square root. So when you take the square root of a number like 49, 7's the answer. So 7 times 7 is 49, so square root of 49 would be 7. So 100, 10 times 10, you're looking for the number that you can multiply by itself to get that number, and that is 10. For 9, it would be 3 times 3, so the square root of 9 is 3. And for 16, that would be 4 times 4, so square root of 16 is 4. So these are called perfect squares because you get a whole number square root. Okay, so moving down the page, simplifying radical expressions. This is what you have seen on Khan Academy this week. Some of you were able to figure it out on your own. Some of you are still kind of struggling. So here we go. Simplifying these radical expressions, we have square root of 20. What we're looking for is factors of 20 that are perfect squares. So for 20, I could break that up into 4 times 5. So I'm going to write that square root of 4 times square root of 5. And that equals square root of 20. And then from here, I'm going to simplify. So square root of 4, that's 2, because 2 times 2 is 4. So we get 2 and square root of 5. I can't simplify square root of 5 anymore. So this is as simple as I can make this. Okay, now we repeat. For B, 54, 9 times 6 comes to mind. So square root of 9 times square root of 6. 9 has a perfect square, so that would be 3 square root of 6. And that's as simple as we can make it. For C, 160, so I think of 16 times 10, with 16 being a perfect square. And then square root of 16 would be 4, square root of 10, and we're done. And then for D, we have 6 and square root of 8, so 6 times, and then 8, I'll break that up. Square root of 4 times square root of 2. And then 6 times square root of 4 is just 2 times square root of 2. 6 times 2 is 12. And that's as far as we can do. Go with it. Okay, that's the general idea. Now we're going to look at it in different situations, but the same concept's going to repeat itself at this point. Okay, so here's the next example. Again, they get a little bit more complicated, but we're literally just repeating the same idea. Square root of 8, I'm going to break that up to square root of 4 times square root of 2 times that last term, square root of 2, just bringing it down. Okay, square root of 4 is 2. And then as I bring it down, I'm going to just cross that out so I know what I'm working with. Then we have square root of 2 times square root of 2. Square root of 2 times square root of 2 is just going to be 2. And then 2 times 2 is 4. Okay, then the next one, B. Same idea, we're just going to kind of break it up and see what we can simplify. 2 times square root of 2 times 3. And then 14, I'll break that up into factors. Square root of 7 times square root of 2. Okay, so 2 times 3 is going to be 6. Square root of 2 times square root of 2, that is just going to be 2. So I bring that down. And then we have square root of 7. So it's kind of like a puzzle. There's no like one way for every problem. Just break it up and then see what you can simplify. And that's all I'm doing. So C. 7 times square root of 5 times 3 times square root of 50. I'm going to break that up. 25 and 2 stands out. 25 times square root of 2. And then 7 times 3 is 21. Again, looking at what I can simplify, square root of 25 is 5. And then square root of 5 and 2, I can't do anything with it. I'm just going to times them back together to get square root of 10. And then 21 times 5 is 105, square root of 10. Okay, next page. So another what if type situation up at the top. Fractions and radicals. Again, looks like I made an extra enter somewhere and the formatting's a little bit off, but this is what it's supposed to look like. Fractions and a radical. What do you do for this? Well, you just do square root of a over square root of b and simplify as needed. Okay, so looking at a couple examples here. So we got square root of 36 over 49, so we just do square root of 36 over square root of 49 and simplify. So square root of 36 would just be 6, square root of 49 is 7. Simplify if you could, but that's it, 6/7. Okay, B, same idea. Square root of 20 over square root of 9. And simplify as you can. Square root of 9, I know that's just going to be 3. And then square root of 20, I'll break that up. 4 times square root of 5. Square root of 4 is 2. And we get this. And that's as simple as we can get it. So we're done. Okay. And of course, moving down. Now what? So these look pretty similar to the other ones. So just starting with square root of 1 over square root of 3. I'm going to move this kind of over here to solve. So square root of 1 is just 1 over and square root of 3. The problem is that you can't have this radical as a denominator. So we have to get rid of that as a denominator. What we do to get rid of it is we multiply by square root of 3 over square root of 3. So I'm essentially multiplying this whole thing by 1 because square root of 3 over square root of 3 is 1. But when I multiply across, I get 1 times square root of 3 is square root of 3. And then square root of 3 times square root of 3 is 3. So now I don't have the radical in the denominator, and I'm good. Okay, now repeat for B. Square root of 3 over square root of 7. Can't have that square root of 7 in the denominator, so we multiply by square root of 7 over square root of 7. Why did I choose square root of 7? Because that's the denominator. That'll get rid of it. Okay, so square root of 3 times square root of 7, square root of 21 over 7. And I can't simplify it any further. Okay, and C, there's different ways you could do C. You could break up 8 if you wanted to first, or you could just multiply square root of 8 over square root of 8. We get square root of 56 over 8. Square root of 56 can be broken up. It might take some trial and error to find the perfect squares in that, or you could just divide by 2 and just keep dividing by 2. That would work. But 4 and 14 are two factors here. So square root of 4 times square root of 14 over 8. 2 square root of 14 over 8. The 2 and the 8 can both be divided by 2. We get square root of 14 over 4. Okay, next. Okay, so now we practice it with all the skills together in these practice problems. Okay, so for this one, square root of 12 over square root of 3. Then I'm going to multiply by square root of 3 over square root of 3 to get that denominator out of the picture. And then we get square root of 36 over 3. And then square root of 36 is 6 over 3, 2. The answer is 2. Okay, and B. Here's a different. I'm going to break this up into vectors. So 27, I'm going to break it up as 9 times square root of 3. 12, break it up as square root of 4 times square root of 3. If you multiplied it by square root of 12 over square root of 12, it would still work out to the same thing. Just FYI. So at this point with it broken up, square root of 3 divided by square root of 3 is just going to cancel, which makes my life easier. And then square root of 9 over 4, square root of 9 is 3, square root of 4 is 2, and we're done. And C, we can't have the square root of 2, it's the denominator, so multiply by this. Get 7 square root of 20 over 2, which we know square root of 20, we can break that up. And then you get 7 times 2 times square root of 5 over 2. You can just cancel out these 2's and get 7 square root of 5. Do you guys like this kind of stuff or not? No. Some of you might. Okay, D. Same idea. I'm going to break up the 15 and the 10. So I'm going to rewrite this. Square root of 5 times square root of 3 for the 15. And 3 times square root of 5 times square root of 2 for the 10. Then in doing that, square root of 5's will cancel. It's still not that pretty. Let's see. Square root of 3 over 3 square root of 2. Still can't have that square root in the denominator. So we do this. So we get square root of 6 over 3 times 2. So square root of 6 over 6. I feel like there might have been a simpler way to do that one. I don't know. Okay. E. Okay, I got 3 square root of 2. Break up the 6. Square root of 3 times square root of 2. This cancels. Then I have 3 over square root of 3. Still can't have that as a denominator though. Then the 3's cancel. And the answer is square root of 3. To me, it's satisfying when it actually looks simpler than the original, but when it gets more complicated, I'm like, wait, why did we do all that work? Okay, then for F, let's see, we could simplify this, the 1 and 10, or to 1 and 5. And then getting rid of the square root of 2, multiply by square root of 2 or square root of 2. I get 5 square root of 10 over 2. And we're done. Okay, so flip to the next page. And this is your independent practice, or AKA homework, on the topic right here. So I want you to try these as best you can. If you have questions, just raise your hand. I can either come over and help you or show everyone what to do. On the board, I do have an answer bank. So as you go through these, if you want to make sure that you're doing it right, let me zoom out so that way those looking at the, so here's the answer bank. So you can check your answers as you go in those problems.